Since its founding over 40 years ago, Ulano has become an industry leader for innovative products that place screen-printed images on an infinite variety of surfaces, shapes, and sizes. As part of an ongoing corporate commitment to provide helpful technical information to our customers, Yulano is pleased to present this step-by-step demonstration of one of its many stencil systems, the Yulano Indirect Film System. In this presentation, you'll see screen preparation, stencil production, including the step wedge test for determining appropriate exposure, and stencil removal procedures. All Yulano products are manufactured to the highest standards and are formulated to enable you to make consistent, trouble-free stencils. Knife-cut and pre-sensitized photographic films are both examples of indirect stencils. After decades of use, knife-cut films still remain an effective choice for many kinds of screen printing, especially for signs. Automated cutting machines can bring knife-cut films from machine to screen quickly, reliably, and inexpensively. However, when printing details are too fine for knife-cut films, pre-sensitized indirect system films offer an excellent alternative. Depending on your application, you may select from many types of Yulano pre-sensitized photographic films. The processing of all of them is similar, although slight differences in processing temperatures and exposure are needed to optimize the results for each product. For the purpose of this particular demonstration, we will be using Yulano GFR. GFR has exceptionally wide exposure, development, and washout latitude. This film is useful on a broad range of mesh counts, and thus is suited for a wide range of printing applications. Before stencil production begins, there are some basic but important preliminary steps to consider. We look first at screen preparation and examine some of the major factors that affect the quality of the print in very important ways. You'll first need to select a fabric that's right for the particular printing application. Keep in mind that the mesh you choose, not the thickness of the stencil, will be the major determinant of the ink deposit. In selecting a fabric for line work, to ensure an accurate print, measure the width of the finest line, positive or negative, to be printed, and select a fabric whose thread diameter is no more than 1/2 that width. If the thread diameter is greater than 1/2 of the line width, the results will not be acceptable. In considering halftone work, multiply the halftone line ruling by at least 4 to determine the minimum mesh count that is appropriate for the job. This will provide sufficient anchorage for the smallest halftone dots. In addition, it will minimize the effect of moire patterns. If the mesh count is too low, the stencil won't have enough fabric to adhere to. It's important to note that only with indirect films can the stencil thickness be controlled by exposure time. A short exposure will yield a thin stencil, and a longer exposure will yield a thicker stencil. For this demonstration, we will use a 90T, 230T in the English system, monofilament white fabric, stretched over an aluminum frame, since wood frames tend to swell and warp. Proper tensioning of the screen will assure good registration and allow even film adhesion. In this demonstration, a stretch and glue frame will be used, but self-tensioning frames are a good alternative when mechanical or pneumatic equipment is unavailable. At this point, the fabric can be prepared to make it more receptive to the emulsion. This assures good stencil adhesion, thereby minimizing premature breakdowns. Synthetic fabrics need to be abraded before use. This initial roughening step enhances adhesion. Start by wetting down the fabric with a thin sheet of water on the print side. Scrub on Ulano No. 2 microgrit. Work the microgrit around on the printing side of the mesh with a stiff bristle brush. Now rinse both sides with tap water. As you can see in these micro photographs, there's a considerable difference between the two fabrics. The sample on the right has been properly abraded and is capable of a much better bond than the unabraded fabric on the left. As a final step before stencil making, all fabrics, metal, silk, synthetic, new or used, must be degreased to remove contaminants. Degreasing should be done as soon as possible before adhering to give dust and dirt as little time as possible to settle on the mesh. Apply Ulano No. 3 screen degreaser liquid with a brush. Thoroughly degrease all areas within the frame, not just the area of the stencil, and degrease both the printing and the squeegee side. Leave the degreaser on for 1 or 2 minutes and rinse. For larger size screens, Ulano Gel 23, a combined roughener and degreaser, offers a convenient one-step method for preparing screens effectively. Brush Yulano Gel 23 on both sides of the wetted fabric. Let it stand for several minutes, and then rinse from both sides. Now that the screen is properly prepared, production of the stencil itself can begin. Because pre-sensitized photographic stencil films must be protected from sunlight and white light from all sources, yellow safe light should now be used. Exposure is a critical step, and without proper exposure distance and exposure time, all the careful preparation could be wasted. The minimum exposure distance recommended for all light sources, except fluorescent tubes, is 1 1/2 times the diagonal measurement of the image. While it's true that the Yulano datasheets give theoretical base exposures, individual lamps and ambient conditions vary greatly. There are several methods to determine what the right exposure time will be, but the most accurate method is the step wedge test. Later on in the program, we'll demonstrate how to conduct the Yulano step wedge test procedure. Upon completion, the operator can be assured that the stencil will be exposed properly. Before making an exposure, take the time to clean both sides of the contact glass to cut down on the chances of pinholes. Indirect films are exposed through the clear plastic base. The emulsion side of the film positive must contact the plastic backing support of the GFR. Processing requires a dense film positive. Good vacuum contact between stencil and positive is maintained using either a hard or soft blanket. Care must be taken with a soft blanket to prevent wrinkles that may form over the film. Yulano stencil films require an exposure source rich in the long UV and visible blue parts of the spectrum. Several types of light sources are available. Metal halide is best because the light emitted is a straight beam, direct frequency that renders a sharp edge definition from positive to stencil. Mercury vapor and pulsed xenon are also good. Fluorescent tubes or quartz lamps are poor but serviceable alternatives for non-critical work because the light they emit is more diffused and won't render a sharp image. At this point, the indirect film is exposed with the film positive for the correctly calculated amount of time. After exposure, the film is developed for 90 seconds in a solution of Ulano A and B developer powder at the recommended temperature between 18 and 24 degrees centigrade or 65 to 75 degrees Fahrenheit. Refer to the labeled instructions for the proper preparation of the developer. Next, the entire surface of the film is washed, emulsion side up, for at least several minutes with water from an aerator nozzle. Follow the recommended washout temperature range for each indirect film. Patience is the key here. Wash gently but thoroughly to dissolve away the protective coating. High water pressure or excessively hot water temperatures used in attempting to speed the washout will damage the soft gelatin. It should be melted by the slightly elevated temperature of the water and simply flush gently. Continue to wash until no more color is rinsed away. A good way to check the thoroughness of the washout is to remove the film from the water. Hold it horizontally for 5 to 10 seconds. Then let it drip on clean white paper. If the drops show color, the stencil has not been thoroughly washed out. After all the unexposed matter is washed away, the stencil must be chilled by gradually lowering the temperature of the washout water to room temperature. The chilling firms the gelatin and returns the stencil to room temperature dimensions. Normal lighting can now be resumed. Before adhering the stencil, re-wetting helps to remove airborne dirt and dust. The washed-out, chilled stencil is placed on the screen with emulsion to the print side of the fabric, and the stencil is gently applied from the center outward, taking care to press out any bubbles or gaps. Place a pad of at least 12 sheets of unprinted newspaper stock on the squeegee side of the fabric. Gently wipe over the paper with a clean rag so that the soft, tacky top of the stencil is blotted into the fabric. Keep changing the newsprint until little or no color appears. Wipe the excess water from the frame and surrounding mesh. Gently wipe the plastic backing sheet and allow the surrounding mesh to dry. When dry, block out all non-image areas with either Ulano number 60 or number 10 screen filler. These products are a safe alternative to hazardous, fast-drying blockouts, and it offers efficiency and convenience because it dries as the film dries. Use either a small plastic squeegee, a piece of chipboard, or cardstock to spread it evenly and thinly over the screen. Gently air or dry with cool air until the stencil is firmly adhered and the plastic backing easily removes. To test, gently press underneath to see if the edge lifts up easily. If it does, peel away the plastic backing slowly and smoothly at a 180-degree angle. Should you find that the stencil is not completely dry, you can still save the stencil by replacing the slightly peeled backing and letting it continue to dry. After peeling, the stencil is ready for printing. The processing of Ulano indirect films is straightforward. However, it may be useful to take a closer look at how to determine the proper exposure time of the stencil. For this, Ulano recommends using a step wedge test. It's a series of 5 incremental exposures, all made on the same stencil. The test uses a film positive, designed to show a wide variety of line thickness, with Rubylith and Amberlith brand masking films. Use the listed approximate exposure time as a starting point. Place the film, with the positive taped on it, in a vacuum frame and expose for 50% of the approximate exposure time for your light source. For the second exposure, tape the masking film in place so that it covers about 1/5 of the positive, and expose again, this time for 25% of the approximate exposure time. Move the mask so that it covers 2/5 of the positive, and expose again for 25% of the approximate exposure time. Continue to move the masking film over 3/5 of the positive, and expose as in the last step. Now covering 4/5 of the positive, the final exposure is made. Of course, the percentages of exposure can be varied as desired, but the end result will still be a stencil with the approximate exposure and 2 exposures above and below this approximate time. Process the stencil as before and dry. When the stencil is ready, make a print from it. After the print dries, compare it to the film positive. Usually the highest exposure consistent with resolution and adhesion requirements gives the best edge definition and greatest wear characteristics. But bear in mind that the finer the printed detail desired, the more carefully overexposure must be prevented. If the film is overexposed, the stencil will be too thick. Fine lines will be undercut, fill in, and may not even print. Indirect films must not be underexposed either. This will result in a stencil that is too thin to withstand the stress of printing. Ultimately, the step wedge test is valuable insurance against wasted time and materials. Now let's look at how to remove the stencil and reclaim the screen after printing. First, remove the ink as soon after printing as possible with the solvent recommended by the ink manufacturer. Then degrease both sides of the screen with Yulano No. 3 screen degreaser to remove oily ink or solvent residues as much as possible. After degreasing, rinse the screen thoroughly with water. If Ulano screen filler was used as a blockout, water can be used to remove the screen filler solution. Apply either Ulano No. 1 enzyme or Ulano No. 15 gelatin film decoder liquid as directed for proper stencil removal. In industrial use, Ulano No. 78 haze remover paste, used with a commercial power spray, will remove ink haze and stencil scum. Ulano wants you to achieve perfect stencils every time. That's why Ulano provides a wide range of highly consistent, pre-sensitized indirect films for selection based on your application, run length, and desired resolution, including Ulano Lux UP3, which requires no chemical developing, and specialty films for critical printed circuit and fine line work. Full information on the range of Yulano indirect films and their recommended applications is available in the Yulano Pre-Sensitized Photographic Stencil Films booklet and in technical literature available from Yulano or your Yulano dealer. Yulano is also ready to support you with sample packets, with demonstrations at major trade shows, with a worldwide dealer network, and with a telephone information service for fast response to your needs. For additional product information about Yulano's high-quality stencil systems, contact your Yulano dealer or technical representative.